Hello everyone, welcome back. So in this video we are going to understand the Leetcode problem number 3488. It's a closest equal element queries, and we have to understand first the question and then we'll understand how to implement this problem. Okay, so let's try to understand the very first the question saying that you are given a circular array nums and an array queries we have given. So for a query I, you have to find some of the things, right? Let's suppose the minimum distance you have to find between the elements at query at I and any other index j in the circular array, where nums at I is nothing but the nums at query at I. If no such index exists, the answer for the query should be -1, and return the array of the answer of the same size as queries, where answer at I represent the result of the query. So pause this video, go through this question statement so you'll understand clearly. Okay, so very first the question saying that nums we have given, okay, and then queries we have given. So at each query, right, what you need to do is we have to find the nums at I, nums at j is equal to nums at query. So for the query 0, as you can see, what we have, if you will put query at 0, is what we have is 0, means nums at 0 is 1. Similarly, for the query at 1, we have 3. So nums at 3 is equal to 0. And similarly, for query at 2, we have 5. And the nums at 5 is 3. So if you see, for nums at 0 is equal to 1, the nearest index with the same value is 2. And so the distance is 2. And similarly, for this value, no index is found here, right? So we'll take -1. And for 3, we don't have any nearest element, but we have the same value we can see at index 1. So we can say the distance we can see like this, okay, as it's a circular one. So it goes from 5, 6, 0 and -1. We'll more understand in the next slide so you can understand. The very first time I want to try to say that if you pause this video, go through the statement and this example so you will understand. Let's go to the slide. So let's suppose that we have given these what you call the queries, right, for this problem, and we'll understand. Okay, so let's suppose that let's go to the slide first. I think you can see the slide, right? Okay, so we have seen this problem. Okay, what the question saying, that question is saying that very first we should understand the problem. So we have given the array, we have given nums and some query index we have given. So for each query index I, we have to find the closest index where j is not equal to I. It means nums at j is equal to nums at I. Okay, so this condition should match. We have to find the closest index. But there is a twist we have. The array is circular we have given, meaning the last index, right, you wrap to the index 0. So let's suppose if the array is look like this, right, so this last index we can navigate back to the first index, and that is called the circular. So we have to return the minimum distance between I and such j we have. So we have to take the distance between I and j and we have to return it. But there is a thing that if no such element is there, we will return -1. But we have to return in such a way that number of queries and number of these minimum distance should be equal. So what is the problem is asking here? The very first thing, that you are given a circular array, meaning after the last element, right, it wraps back around to the first like a ring. Okay, so you are also given a list of queries where each query is an index into the array. For each query index, you need to find the shortest distance along the circular ring, so to any other position in the query that holds the same value. If no such match we have, right, exists, will return -1. So the key concept what we have is the circular distance. How will you find the circular distance? So in normal array, the distance between indices I and j is just, you need to do I minus j, you will do, and you can find it, right? But in a circular array of length n, you can also go to the other way around, right? Let's suppose circular distance, if you want to find with the I and j, you can find minimum of I minus j in comma n minus I minus j, we can say that, right? So we can find the circular distance like this. Okay, I hope you understand. Then think of it like a clock. From 3 o'clock to 11 o'clock, you can go to 8 step clockwise and 4 step backwise, right? So if this is a clock we have, right? So let's suppose if you want to find from here, right, you can go to how many steps, and if you want to go from this way, how many steps you will go, right? Like that you can think about it like a circular what you call the watch or clock. So the queries on a circular array, we have to find the shortest distance to the same value in the ring. So you can find the distance, right? So for any value, if you want to find, there can be multiple distances, and based on each queries, you have to find the distance. If match is found, then we'll return the distance. If match not found, we'll return -1. Okay, so the result will become is 2, 3 and -1. Number of queries is equal to number of answer we have, right? So we have to find the shortest path to matching the value in the ring. So if no match exists, we'll return -1. Okay, so what is the circular wrap? Circular wrap means we have given this array, so these are the indices. At each indices we can see the value, right? But this is the last index, we can see that, right, from where it start moving back to the first one. So the last element is moving to the first one, right? So this is the way we can say that it wraps to the index. Okay, now if you query index 4, right, let's suppose we'll talk about this one. Okay, index 4, that is value is 5 with n equal to 6, right? So there is no other 5, right? But if the problem had 1 at an index, the clockwise distance is 3 and the counterclockwise distance is also 3, so both paths are checked. So summary is that for each query index hop around a circular array, the shortest path, either the direction, either clockwise, anti-clockwise. Then we find the nearest copy of the same number and we'll say return -1 if not exist. So let's suppose that we have given this array, we have given this query, and number of elements in the nums is 7. So the expected output is 3, because number of queries is number of output, we can say, or answer. Let's suppose that this is the array we have, we will represent this. These are the indexes we have given, right? So for query at 0, right, what we have, index is 0. As you can see, at index 0, with the query 0, this is query 0, we can say that, and at index 0 we have 0, right? And what is the value we'll get here? So value, let's suppose we'll get is 1, right? So nearest match, if you want to find for the index, is 2. So clockwise will go from 0, 1, 2, right? Means total how many steps we will go is 2 steps we will go, right? 0 to 1. Then if you will go counterclockwise, from 0 you will go 6, 5 and 4. So total how many steps will be there? 3 steps we have. So minimum is 2. Between 2 and 3, what is the minimum steps? We have 3. Similarly, if we will go for the query 1, the index is 3, right? So value is equal to 4, right? Means we are talking about this one. Now the value 4 appears only in the entire query array, right? So if you see here, right, these are the things we have given. Okay, so let's suppose value 4 appears only in the entire array, so no match found, so we'll return -1. Okay, now we'll go for query 2, where index is 5 we have given, right? The value is equal to 3 we have given. Okay, so index 5 is nothing but value, we are talking about this one, right? This array array value, we can say that, right? So match found at index 1, right? So clockwise, if we'll go 5, 1, 5, 6, 0, 1, so there is a 3 steps we found, and counterclockwise will go 4 steps we will found, so total minimum is 3. It means the optimal approach is that we will double the, how we will do this implementation, right? So double the array, append a copy, and then use 2 hash maps. We'll do the swapping, one from left to right and one from right to left, and then we'll find the position which is nearest to the neighbors, right, equal to the neighbors. So through the each step, right, let's suppose this is the original array we have given, so we'll start from this given array, and we need to find every index how the closest nearest value is. So let's suppose this is array we have. Okay, So very first step what we need to do is we have to double the array. It means half of this array will be there and half of the array we will add it again back to the array, right? So we will do plus, okay, means we will double the array. That is called the double the array. So to handle the circularity without tricky modulo, we will logically extend the array to the length of 2n, and index 7 mirror index 0, index 8 mirror index 1, and so on. We will say that, right? So it means this is the last element we had in the array. If we want to go back to the circular one, so we'll not go here, we have directly here at this place, means we have the mirror of the 7 index to here, we can say that. Okay, now let's go to the step 2 where we'll do the left pass and we'll scan from 0 to 13, means we will start from here and we'll do a scanning till the last index, right? Means from 0 to 13. So we'll scan from left to right on the double array. We'll take a hash map for the left track and the last position each value was seen, right? And when the when we see the value 1 again at index 2, let's suppose, so we'll say 2 minus 0 is 2. Okay, so at left at 1 is 0, I is equal to 2, right? So distance at 2 will take infinity, 2 minus 0 is nothing but 2. So we'll calculate like this. As you can see, we have marked with the red color so you can easily understand, right? So we'll find the distance from here to here, we'll got is 2. Now continue the step 2 where we'll continue the left pass and we'll check the another value. Okay, so continuing the left pass, we see value 1 at index 4, last seen at index 2. So the distance is 2 will get, and we'll update the distance. So we'll update the distance and we'll say, okay, left at 1 is nothing but is 2. So at I equal to 4, we saw that we have element, right? So we saw that here and here we found that element we have, right? So we'll find the distance. 4 minus 2 is nothing but 2 will get, so we'll update d at 4. Similarly, we'll continue the step 2 only, left pass, and we'll see 3 at index 5. So we'll say, okay, index 5 and index 1 have the same value, so we'll check 5 minus 1 is 4 and we'll get the index 4 as it. So we'll update our d at 5. Similarly, we'll move to the step 3, right? We'll continue the right pass. This time we'll do the right pass. Now we can scan from right to left side, right? Like this we will go for the scanning on the same double array, and the hash map will take the right track as we have done for the left track, right? And we'll check the next position for each value, and this catches the distance going in the other direction and counterwise in the original. So we'll scan the element, right, from I equal to 13 from here and down to the I equal to 0, we can say, and we'll update di at I. How? D at I and right at the value minus I. Let's suppose we'll continue the step 3, right? We'll do the same thing. So we during the right pass we find that value 3 at index 8. So index 8 have the value 3 and index 5 we have the value, right? So for each index, right, let's suppose now 5, d at 5 we'll check the minimum value. So 4 minus 8 minus 5 is equal to 3, right? So we'll say, okay, we will update the value similarly. So this capture the shortest circular wrap around path. We'll answer the query, right? So for each query we have seen that d at q and d at q plus n. So if the result is greater than or equal to n, return -1. If no matches exist, otherwise we'll put the value. So queries we have 0 0 3 5, right? So we have seen the query 0 3 and 5. We will update the d at 0 and d at 7, d at 3 and d at 10, d at 5 and d at 12. Like that we will keep all those values. So that we'll create the final answer. We'll see that the query got is distance to, well, -1 and distance we got is 3. So we'll update, this is our answer becomes, right? I hope you understand. So in this way we'll do the left and right pass and we'll create the answer. Okay, we'll do the solution, we can say, basically. So the key insight what we have is for every index, right, the closest equal element is the main thing we have, right? Either we are going from left or right, right? We have to find the closest element, means we want to find the distance, right? So we'll produce both distances for every index, either you go to the left or right, right? Or we can say, and we'll take the minimum one, right? One pass we'll do from this side and one pass from this side, and we'll check that. Now to handle the circular without a special case wrapping around, we double the array. Like ABCD we have, so we'll say ABCD 2 times, so it become double the array. Now any circular neighbor of the index I is the original array appears within the distance n in the double array, correct? So the algorithm says that there are some steps we have. So very first we'll double the array, means if we'll do the length of 2n and we'll initialize the array in d to n is nothing but like d at 2n is nothing but infinity. So very first we'll do the left pass, so we'll scan from left to right, we can say. We'll track the last seen index for each value. When we see the value again, so we'll record that value in distance at I is nothing but the minimum between the d at I and I minus last seen value. Similarly, we'll do the right pass, we'll scan from right to left this time, and same idea we'll do. We'll find the nearest equal element which is coming from the right, and for every index q we'll find the mean at q is dq we can say at dq plus n. So if no match is there, we'll return -1. Then let's go to the code. So as you can see, we'll fill with the infinity, right? We'll create the array. So we'll take the original size is m, original size is nothing but is n, so we'll create m is a 2n, right? And we'll create the distance array. We'll fill that array with the infinity. Now we have to go for the right to left to right, right, scan. So we'll create a left hash map, right? And we'll check this same thing. So very first we'll get the value, right? And we'll check if the left contains that value. Otherwise we'll take the minimum and we'll update the di. So we'll put on the left hash map. Similarly, we'll go for the right hash map, right? And we'll check again with the value will go, and this time we'll go from the right to left, right? So I become a -1 and we'll go until the 0. And similarly, we'll calculate the val, then we'll check the right index contains, right hash map contains this value, right? If contains, then we'll find the minimum between the di and the right at, we'll get the value -I and we'll update the di. And we'll put the right at put, we'll add the value, and we'll keep updating like this. And in the finally we'll do what, we will update the answer. So we'll create an answer array for each query. We'll find the minimum between the dq and dq plus n, and we'll find the best, and we'll put the best if it is not greater than equal to n. If it is greater than equal to n, means we will return -1. Otherwise we'll put that best as an answer. Then finally we'll return the answer. So this is what we have in this video. In case if you have any doubt in this code, please let me know in the comment section. I'll explain. Now coming back to the complexity. So if we'll talk about the complexity, it become O of n plus q, and complexity, space complexity of n, because we have doubled the array, right? And we have taken the hash map also. Okay, so that's all I have in this video, guys. In case if you have any doubt, please ping me in the comment box, and thank you for watching this video. Like, subscribe this channel, and if you have any suggestion, please put me in the comment box, right? And yeah, that's all I have in this video. Thank you for watching this video, and I'll see you in the next one. Thank you.